Next, I will explain the research question, objective, and method used in the study. First, the research questions. This study addresses three main questions. The first question is to identify the trend of food availability in Malaysia during periods of global conflict. The second question examines how geopolitical risk, supply chain disruption, crude oil prices, urea prices, and inflation influence food availability in Malaysia. The third question focuses on determining the long-run relationship between geopolitical risk, supply chain disruption, and food availability during war periods. Based on this question, the research objectives are developed. The first objective is to analyze the trend of food availability in Malaysia. The second objective is to examine the influence of geopolitical risk, supply chain pressure, crude oil prices, urea prices, and inflation on food availability. The third objective is to measure the long-run relationship between these variables and food availability in Malaysia. To achieve this objective, the study uses a combination of descriptive analysis and econometric methods. The descriptive analysis is used to identify trends in food availability using data from sources such as World Bank and DOSM. Meanwhile, the relationship between variables is examined using the autoregressive distributed lag or ARDL model supported by data from sources such as CPR Index, GSCPI, World Bank, IMF, and FAO. Overall, this methodology allows the study to analyze both short-run and long-run effects of global factors on food availability in Malaysia. I will begin by explaining the research issue for our study. Today, food availability has become one of the biggest global concerns due to the increasing number of geopolitical conflicts such as the Russia-Ukraine war and the ongoing tension in the Middle East. This conflict has disrupted global agricultural production, transportation, and food distribution, resulting in food shortage and higher food prices worldwide. Malaysia is particularly vulnerable to these external shocks because our country depends heavily on imported foods, fertilizers, animal feed, and other agricultural inputs. When international supply chains are disrupted, Malaysia experiences delays in imports and higher logistic costs, which directly affect the availability of food in the domestic market. In addition, rising crude oil prices, fertilizer prices, and transportation costs increase the overall cost of food production and distribution. These higher costs are eventually passed on the consumer through increased food prices. At the same time, inflation reduces consumer purchasing power, making it more difficult, especially for low-income households, to afford essential food items. Although the Malaysian government has introduced several initiatives, including food subsidies, price controls, and programs to strengthen domestic food production, significant risks to food availability still remain because global supply chain disruptions continue to occur. Furthermore, previous studies have mainly focused on individual factors such as geopolitical risk or supply chain disruption separately, and many were conducted outside the Malaysian context. Therefore, our study aims to examine the combined effects of geopolitical risk, global supply chain pressure, crude oil prices, urea prices, and inflation on food availability in Malaysia. We hope the findings will provide useful evidence to support better food security policies and improve the resilience of Malaysia's food supply chain.
Moving into next section, our literature review focuses heavily on how organized conflict or war directly disrupt global food supply chains and limit overall food ability. Recent academic consensus point out the geopolitical challenges have pushed many nations to adopt protectionist stance to secure their own domestic food system. When a war breaks out, it triggers a domino effect interrupting agricultural production, halting the logistic and transportation of goods, serving fertilizer supply serving fertilizer supply line, and closing critical trade channels. As a net importer, of a wide variety of agricultural goods and inputs. Malaysia particularly vulnerable to these external shocks. Therefore, understanding these drivers is critical for us to design resilient nation food security policies. Let us look at geopolitical risks. According to Foundational Research, geopolitical tensions inject uncertainty into international markets. This uncertainty manifests as sudden shipping routes disruption, spiked transportation costs, and chronic delays in international trade. This heavily impact commodity pricing and market stability. Furthermore, contemporary studies in 2025 proved that countries with a high reliance on imported food products suffer far worse from the external shock compared to the nation with robust domestic production system. A prime real-world example noted by the FAO in 2024 was the Russia-Ukraine war, which crippled global export of essential wheat, maize, sunflower oil, and fertilizer, immediately plunging multiple importing nations into food shortage and high inflation. Now we look into the mechanic of supply chain disruption. These are defined as operational breakdowns spanning production, logistics, transportation, and delivery. In modern interconnected food network, resilience in everything. Research by Liu in 2025 demonstrate the nation with diversified supply chain network and superior logistic infrastructure are significantly more successful at maintaining steady food availability during a crisis. Looking domestically, Sarbani in 2025 evaluate the Malaysia food retail sector, discovering that transport delay, inventory shortage, and excessive supplier dependence heavily reduce food delivery efficiency. Now let's look at crude oil prices. Modern farming and transportation depends heavily on energy. While global oil prices go up, the cost to transport, store, and produce food goes up too. This shrink that actually supply of food in the market and pushes prices higher for consumers. Major international organizations like the World Bank and OECD agree that oil price volatility is a major cause of supply chain disruption worldwide. During global conflicts, oil prices spike makes it much more expensive for imports dependent countries like Malaysia to keep food availability and affordable. Now let's talk about urea, which is one of the most common fertilizer used by farmers to grow crops. Because of conflict like the Russia-Ukraine war, global fertilizer export and natural gas supplies were heavily disrupted, causing urea price to skyrocket. When fertilizer get too expensive, local farmers face massive production costs. As a result, they produce fewer crops, which directly reduce the amount of food available in the market. Recent research shows that fertilizer shortages aren't just a short-term issue, they are a serious long-term threat to our food supply chain. Finally, we look at inflation. Inflation reduces food availability in two main ways. First, it hurt the consumers' wallets. When price climb, families simply cannot afford to buy as much food. Second, it raises the cost of farming inputs and logistics for businesses. The World Bank notes that during global crisis, high inflation makes it very difficult for both businesses or governments to keep food markets stable. It's also make government food aid and subsidy programs much more expensive to run. In short, inflation multiplied the damage already caused by geopolitical tension and supply chain failure. We identify four major gaps in existing research. First, past studies look at the global shocks like geopolitical risks, oil prices, fertilizer costs, and inflation completely separately. Our study is unique because it combines all these variables into a single framework to measure their impact. Second, there is a geographical gaps. Most food security research targets Africa, Europe, or giant Asian economies. Since Malaysia relies heavily on imported food and agriculture inputs, we need localized empirical data to understand our specific risks. Third, we fill a theoretical gaps by synthesizing supply chain and food security framework with supply and demand, production and trade theories. Finally, instead of using basic descriptive or qualitative data like past research, we fill a methodological gaps by using the ARDL model. This advanced tools allows us to accurately test both short run and long run relationship at the exact same time. This provide Malaysian policymakers with a concentrate, reliable strategy to safeguard national food security.
Next, I will present the descriptive statistic for all variables used in this study. Descriptive statistics are used to summarize the characteristics of the data, including the mean, standard deviations, skewness, and kurtosis. Starting with food availability, the results show low variation throughout the study period. However, the high skewness and kurtosis indicate that there were several extreme observations during certain periods. For geopolitical risk, the findings show significant fluctuations over time, suggesting that geopolitical uncertainty was unstable and occasionally experienced sharp spikes. The Global Supply Chain Pressure Index, or GSCPI, fluctuated around its normal level, but there were periods of severe supply chain disruptions that affected global trade. Meanwhile, a crude oil average price showed moderate price fluctuations with a relatively balanced distribution, while urea price was much more volatile, reflecting sharp increases in global fertilizer prices during certain periods. Lastly, inflation remained at a moderate level, although temperature increases were observed over the study period. Overall, the descriptive statistics indicate that the variables have different levels of variations and are not normally distributed. Therefore, these characteristics support the use of the ARDL model, which is suitable for analyzing variables with different order of stationarity. So this is the table 5.1 descriptive statistic. The key point is food availability is quite stable with a mean of 0.0384. Geopolitical risk is high volatile, showing big chances during the period. Urea prices is the most volatile variable compared to others, and overall all variables show different level of fluctuations, which supports our analysis using the ARDL model.
Next is the normality test. The normality of the variable was tested using the skewness and kurtosis test in Stata. The null hypothesis states that the variable is normally distributed. If the p-value is greater than 0.05, the variable is considered normally distributed. On the other hand, if the p-value is less than 0.05, the variable is not normally distributed. Based on the result, our variables, including food availability, geopolitical risk, GSCPI, crude oil price, urea price, and inflation, have p-values below 0.05. Therefore, the null hypothesis is rejected, indicating that all variables are not normally distributed. This result is expected because the variables represent macroeconomics and geopolitical conditions which are often affected by global crises, supply chain disruption, and geopolitical conflicts that create extreme values and asymmetric distribution. However, this does not affect the analysis because the ARDL model does not require the variables to be normally distributed. Therefore, the next step is to conduct the augmented Dickey-Fuller or ADF unit root test to determine the stationary of each variable before estimating the ARDL model. Next, I will discuss the result of ADF unit root test. The purpose of this test is to determine whether each variable is stationary at level known as I0 or becomes stationary after first differencing known as I1. This step is important because the ARDL model can only be applied when the variables are integrated at I0, I1, or a combination of both, provided that none of the variables is integrated at I2. The null hypothesis states that the variable contains a unit root and is non-stationary. The null hypothesis is rejected when the McKinnon p-value is less than 0.05, indicating that the variable is stationary. Based on the result, food availability, geopolitical risk, GSCPI, and inflation are stationary at level or I0. Meanwhile, crude oil average price and urea price are not stationary at level but become stationary after the first difference, meaning they are integrated of order 1 or I1. Overall, the findings show that the variable consists of a mixture of I0 and I1 with no variable integrated at I2. Therefore, the data satisfy the requirement for estimating the ARDL model and the analysis can be proceed to the next stage. After confirming that all variables are integrated at either I0 or I1, the ARDL model was estimated to examine the relationship between geopolitical risk, global supply chain pressure, crude oil prices, urea prices, inflation, and food availability in Malaysia. The estimated model is ARDL 1000000 based on 320 observations from May 1998 until December 2024. The model recorded an R-squared of 0.4311, which means that about 43% of the variation in food availability can be explained by the selected independent variables. The adjusted R-squared also indicates satisfactory explanatory power, while the RMSE value is relatively low, suggesting that the model produced relatively small prediction errors. Overall, the model is appropriate for analyzing both the short-run and long-run relationship among the variables. Next, I will explain the long-run relationship estimated by the ARDL model. The result shows that geopolitical risk has a positive and statistically significant effect on food availability. This indicates that changes in geopolitical conditions significantly influence Malaysia's food availability through disruption in international trade and food supply chain. The Global Supply Chain Pressure Index has a positive coefficient but is not statistically significant, suggesting that supply chain pressure does not have a long-run effect on food availability during the study period. For crude oil price, the relationship is positive and significant at the 10% level. This implies that changes in oil prices affect transportation, production, and distribution costs, which eventually influence food availability. Meanwhile, the urea price has a negative and significant relationship with food availability. Higher fertilizer prices increase production costs, reducing agricultural productivity and food supply in the long run. Lastly, inflation shows a positive and significant relationship at the 10% significant level, indicating that rising prices influence the food system and consumer purchasing power. Overall, the long-run results show that geopolitical risk, crude oil price, urea price, and inflation significantly affect food availability in Malaysia, whilst GSCPI does not have a significant long-run effect.
Next is the error correction model, or ECM. The purpose of the ECM is to measure how quickly the system returns to its long-run equilibrium after experiencing short-run shocks. Based on the result, the error correction term, or ECT, is negative and statistically significant, with a coefficient of negative 0.8226 and the p-value of 0.000. This satisfies the theoretical requirements of the ECM and confirms that there is a stable long-run relationship between food availability and the explanatory variables. The coefficient also indicates that approximately 82.26% of any short-run disequilibrium is corrected within one period. This means that food availability adjusts relatively quickly after the shocks, such as geopolitical conflict, supply chains distributions, changes in crude oil prices, urea prices, and inflation. Overall, the significant ECT confirm the validity of the estimate ARDL model and support the existence of a stable long-run relationship between the selected variable and food availability in Malaysia.
Our study successfully achieved its main objective, which was to evaluate the long-run impact of global geopolitical risks and macroeconomic shocks on food availability in Malaysia over the period from May 1998 to December 2024. Based on the long-run estimation result, we identified several significant determinants of food availability. First, geopolitical risk, or GPR, has a positive and highly significant effect with a p-value of 0.00. This suggests that geopolitical events play an important role in shaping long-term adjustment in Malaysia's food market. Second, urea price has a negative and statistically significant relationship with food availability with a p-value of 0.013. This indicates that rising fertilizer costs increase production expenses, reduce agricultural output, and ultimately lower food availability. Next, crude oil prices and inflation are both significant at the 10% significance level, with p-values of 0.080 and 0.098 respectively. These variables reflect the impact of higher transportation, production, and overall operating costs on the food supply system. In contrast, the Global Supply Chain Pressure Index, or GSCPI, was found to be statistically insignificant with a p-value of 0.04. This suggests that while supply chain disruption may affect food availability in the short term, they do not have a lasting impact on Malaysia's long-run food availability. Finally, the error correction model, or ECM, shows an error correction term of negative 0.8226, which is highly significant with a p-value of 0.000. This confirms that a stable long-run relationship exists among the variables. It also indicates a very high speed of adjustment, where approximately 82.26% of any short-run disequilibrium caused by internal shocks is corrected within one period, allowing the system to return quickly to its long-run equilibrium. Overall, this finding demonstrates that geopolitical risks, fertilizer prices, crude oil prices, and inflation are the key long-run determinants of food availability in Malaysia, while temporary global supply chain disruption do not produce permanent effects. Based on the result of this study, several recommendations can be made. First, Malaysia should strengthen domestic food production by supporting local farmers and adopting modern agricultural technologies to reduce dependence on imports. Second, supply chain resilience should be improved by diversifying import sources and enhancing logistics system to reduce disruption during global crises. Third, policies should be implemented to stabilize fertilizer prices and control inflation, as these factors significantly affect food availability. Fourth, the government should also reduce the impact of crude oil price fluctuation, especially on transportation and production costs. Finally, future research is encouraged to include additional variables such as exchange rates, climate change, and government policies, or use alternative econometric methods for deeper analysis. In summary, these steps are important to strengthen Malaysia's food security and ensure long-term stability in food availability.